welcome to the Deep Dive. Look, the world of artificial intelligence is moving so incredibly fast. It's easy to feel like you're just drowning in information, right? So our mission here is always the same. Cut through all that noise, distill the most important insights, and give you that shortcut to being genuinely well-informed. Today, we're diving into something that's not just interesting, it's really flipping the script on how we build AI. We're talking about the agentic shift. We've all been wowed by these powerful individual AI models, haven't we? GPT-4, Claude, Gemini, amazing stuff. But what if the next big leap isn't just about making one AI even smarter, but about getting a whole, team of specialized AIs to work together, collaboratively, like a really good human team? That's the core idea today. It feels like finding a shortcut, almost, to solving problems that seem completely out of reach for any single AI, no matter how brilliant it is.
Exactly. And that's where CrewAI comes in. It's fundamentally a framework designed to orchestrate these AI teams. So in this deep dive, we're going to unpack what this agentic shift really means for AI's future, how CrewAI actually lets you build and, crucially, deploy these sophisticated systems. And we'll also cover the essential practices for managing them in the real world, once they're actually running, because that's a whole other challenge.
Yeah. Get ready for some, I think, some real aha moments. Because this approach can lead to capabilities that are genuinely surprising. Feels like a fundamental change in how we think about building intelligent applications. Definitely a game changer. Okay, so we've all seen the power of large language models, LLMs. They write, they translate, they brainstorm. It's honestly pretty amazing. But I always find myself wondering, okay, what's next? What's beyond just one big monolithic AI trying to do everything? What are the limits there?
That's the perfect question to ask, because the agentic shift is precisely the answer to that. It's a really significant evolution, moving us beyond those powerful but ultimately isolated single LLMs. So imagine instead specialized AI agents. They don't just act alone. They actively collaborate, they delegate tasks to each other, they reason together to solve complex problems. This whole new paradigm lets us tackle challenges that are just, beyond what any single AI could handle on its own. Think of it like building an AI dream team, where every member is a specialist in their field.
Okay, let's unpack that. Because when I first heard AIs working together, my initial thought was, okay, isn't that just like chaining prompts, one output feeds the next input? So how exactly does CrewAI make this real collaboration happen? What makes it different?
That's a really great distinction, and it's absolutely critical. CrewAI is a Python framework, right? And it's specifically designed for orchestrating these role-playing autonomous AI agents. Its real power isn't just passing data along. It's about facilitating genuine collaboration, and it achieves this through defining some pretty sophisticated interaction models. For example, you can set up a process.sequential flow. That's like an assembly line, task A, then task B, then task C, very linear. Or you can go for process.hierarchical. Now that's interesting. You have a manager agent coordinating the whole workflow, delegating tasks to other agents, and then synthesizing their results.
Like a mini org chart for the AI team.
Exactly, like a little corporate structure. It lets the AI manage complexity, synthesize diverse inputs, kind of like a human project manager would. So it really shifts your focus. You're not just engineering prompts anymore, you're designing the system, the collaborative architecture. CrewAI even offers two main paradigms for this. There are crews, which are great for autonomous collaboration, letting intelligence kind of emerge. Think of it like a startup team, brainstorming, good for open-ended tasks. And then there are flows. These are more structured, more like that assembly line I mentioned, better for processes that need to be event-driven or manage state over time, like a financial analysis that might take days and needs to save its progress.
Right, so you choose the structure that fits the problem.
Okay.
So if we're building these AI teams, these crews, what are the fundamental pieces? What are the essential building blocks we need to understand for a CrewAI system?
Good question. There are really four core components that work together. First, you have the agents. These are your autonomous AI entities. Each one gets defined by a role, what they are, like senior financial analyst, a goal, what they're trying to achieve, and a backstory. And these attributes aren't just fluff, they're like the agent's DNA. They really dictate how it behaves, how it approaches problems. A financial analyst agent thinks very differently from, say, a creative content writer agent. Agents can also use specific tools, they can delegate tasks to other agents if needed, and they maintain memory of what's happened.
That sounds incredibly powerful. But I imagine getting that backstory and goal just right is key, isn't it? Like, that's where the real nuance comes in.
Absolutely. That's often the biggest misconception. People think, oh, just give it a name. But the real magic happens when you carefully craft that goal and backstory. You're basically giving it a persona, a purpose. Get that right, and the agent's behavior starts to align almost uncannily with what you intended. It's pretty cool when it clicks. Okay, next up, tasks. These are the individual jobs you assign to your agents. Think of them as atomic units of work. And crucially, each task needs a very clear description what exactly needs doing and an expected output. That last part is vital. It defines what success looks like for that task. It guides the agent.
Like a really specific work order for each team member?
Precisely. Then we have tools. This is how agents interact with the world outside their own knowledge base. Tools are essentially functions. They could be anything, a web search capability, access to a database, calling a custom API, sending an email, whatever the agent needs to do its job. This is how they get their, superpowers to connect to real-time data or external services.
Right, so they're not just stuck inside the language model.
Exactly. And finally, you have the crews. This is the top-level orchestrator. The crew brings together your group of agents and their assigned tasks. It defines the overall collaborative structure, the process they'll follow, sequential, hierarchical, whatever you set up. It's the team lead, making sure everyone works together towards the final goal.
Okay, so just to make sure I've got it. A crew orchestrates a team of agents. Those agents execute specific tasks, and they often use tools to get those tasks done.
You got it. That's the core loop.
It really does sound like a well-oiled machine when described like that. But the immediate question that pops into my head is safety. How do you ensure this team doesn't, go off the rails or start doing things you didn't intend?
That's a critical consideration, especially as these systems get more complex. We'll definitely touch on reliability and guardrails later when we talk about MLOps. It's a huge part of making these production ready.
Good, good. Okay, let's get practical. Now, for the hands-on part, how do you actually build one of these? Our sources mentioned a really cool financial analysis crew example. Where would someone even start?
Right. The starting point is usually setting up a solid project structure. CrewAI actually provides a command line tool, CrewAI Create, which is super helpful. It scaffolds out a standard project layout for you. The neat thing is it separates your configuration, like your agent definitions, task descriptions, into YAML files.
Oh, YAML. Okay, so not code.
Exactly. The agent backstories, goals, task details are in these simple YAML files. Your actual application logic, the Python code that runs the crew, lives separately. The separation is great for maintainability. It also means potentially non-coders, maybe a domain expert, like a real financial analyst could actually tweak an agent's backstory or refine a task description directly in the YAML file without touching Python.
It's clever. Makes collaboration easier.
Definitely.
Yeah.
So for that financial analysis example, let's imagine we use the tool. We'd end up defining our team of 3 specialists in those YAML files. We'd have our research analyst, their goal, gather, interpret, summarize news, SEC filings, market sentiment. Then the technical analyst, their goal. Analyze historical stock data, find trends, patterns, technical indicators like moving averages or RSI. And finally, the investment advisor. Their goal is to take everything from the other two, synthesize it, and produce an actionable investment recommendation: buy, sell, hold with justification. And again, you carefully define their role, goal, and backstory in the YAML to really shape how they perform those functions, like giving each AI its own little expert profile.
Okay, this is where it gets really interesting for me. You mentioned tools earlier, connecting agents to the outside world. How do we build custom tools? Like for that technical analyst, they absolutely need historical stock data. How do you build a tool for that, something robust enough for a real application?
Yeah, custom tools are absolutely vital. This is where CrewAI goes beyond just being clever prompts and becomes real software engineering. General tools are fine, but for production, you need tools that interact with your specific data sources, your internal APIs, your services. So let's walk through building that stock data tool conceptually. First, and this is crucial for production, input validation. You do something like Pydantic and Python to define a very strict schema for the inputs the tool expects. Like, it must receive a valid stock ticker symbol. This prevents the LLM from sending garbage data to your tool. It's like a contract.
Ah, so you're validating what the agent tries to give the tool.
Precisely. You don't trust the LLM blindly. Second, the tool implementation itself. You define a class or function, maybe using CrewAI's tool decorator or subclassing base tool. The core logic lives inside a specific method, usually called run. This is where you'd put your code to actually fetch the data, maybe using a library like eFinance to get stock prices. And third, absolutely critical, robust error handling. Inside that run method, you wrap your code in try.except blocks. What if the ticker symbol is invalid? What if the external API is down? What if there's a network hiccup? Your tool needs to catch these errors gracefully.
Instead of just crashing the whole process.
Exactly. It should catch the error, maybe log it, and return a helpful error message back to the agent. Something like, sorry, I couldn't fetch data for that ticker. It might be invalid. This lets the agent potentially try something else, or at least report the failure cleanly. It builds resilience.
Okay, that makes a lot of sense. So we've got our specialized agents. They have their custom error-proof tools. How do we make them actually work together? How does the information flow from, say, the research analyst to the investment advisor?
This comes down to defining the tasks properly and orchestrating the workflow. In your tasks.yaml, or wherever you define tasks, you give each task its clear description and expected output. But the key for information flow is often the context attribute within a task definition. So for the final investment report task assigned to the investment advisor, you'd specify that its context should include the outputs from the research analyst task and the technical analyst task.
So you're explicitly telling it which previous results to use as input.
Exactly. CrewAI handles passing that information automatically based on the task dependencies you define. It's like saying, hey, investment advisor, before you start, make sure you have the research report and the technical analysis. It enables that seamless flow. Then, in your main Python script, often called crew.py or similar, you assemble the crew. You instantiate your agents, instantiate your tasks, linking them via context, and put them together in a crew object. You also specify the process, like process.sequential for our financial example, ensuring they run in the right order. And finally, in your entry point script, like main.py, you kick off the crew's kickoff method, providing any initial inputs needed, like the company name Tesla, for instance. You can then run this whole thing, often using a command like CrewAI run.
Okay, wow. So you can define the team, their tools, their tasks, the workflow, and then just kick it off with an input. That's powerful running locally. But, for a real-world app, running it on your laptop isn't enough. You need it accessible, reliable, scalable. How do we take this financial analysis crew and deploy it as, say, a web service that other applications can call?
Great question. For professional deployment, the first step is almost always containerization with Docker. I'd say it's pretty much non-negotiable. Docker packages your entire CrewAI application, the Python code, all the libraries it depends on, CrewAI, Finance, Pydantic, etc., maybe even system dependencies into a single portable image. A container.
Like a self-contained box for your app.
Exactly. It guarantees that your application runs exactly the same way, whether it's on your machine, a colleague's machine, or more importantly, in the cloud. Consistency and reproducibility. You define this in Docker file. It specifies things like the base Python version, setting up the working directory, installing dependencies, exposing the network port your app will use, like port 8000, and the command to actually start your application.
Okay, so Docker packages it up nicely. How do you make it accessible over the web?
That's where serving with the FastAPI backend comes in. FastAPI is a modern, fast Python web framework. It's excellent for building APIs. You'd essentially wrap your CrewAI logic inside a FastAPI application. You create an endpoint, maybe a post-request endpoint at Analyze. This endpoint would accept the input, say, the company name in the request body as JSON. When a request hits this endpoint, your FastAPI code triggers the CrewAI kickoff process for that company. Once the crew finishes its work and generates the investment report, your FastAPI endpoint returns that result back to the caller, probably also as JSON. You'd typically run this FastAPI using an ASGI server like Uvicorn, which is built for high performance.
Got it. So Docker packages it, FastAPI exposes it as an API. Where does it actually run?
That's the cloud deployment piece. Once you have your containerized FastAPI application, you can deploy it to various cloud platforms. Think services like AWS Lambda or Google Cloud Run. These are often serverless platforms, meaning you provide your container and the cloud provider handles running it, scaling it up if lots of requests come in, scaling it down to 0 if it's idle. Very cost-effective and scalable. Or platforms like Railway offer similar easy deployment experiences.
Okay, that makes sense for deploying the CrewAI application itself. But what about those specialized machine learning models we talked about? Like if I have a custom PyTorch model for sentiment analysis that I want my research analyst agent to use as a tool, how does that fit into this deployment picture? Does it go in the same container?
That's a really important architectural point. Typically, you would not put a heavy ML model like a PyTorch model directly inside the same container as your CrewAI application. The separation of concerns, mainly, and specialized needs. ML models often have very different dependencies, resource requirements like GPUs, and scaling patterns compared to the main application logic. So the common practice is to deploy that custom ML model as its own independent microservice. You train your PyTorch sentiment model, then package it up, maybe also using Docker, and deploy it behind its own API endpoint. You might use FastAPI for this too, or maybe a more specialized ML serving framework like TorchServe.
TorchServe, what's the difference there?
Well, FastAPI is great, super easy for general APIs. TorchServe is specifically optimized for serving PyTorch models at scale. It has built-in features for handling high concurrency, model versioning, A/B testing models, things that are really important for production ML inference, but might be overkill for a standard web API. It often has a steeper learning curve, though. So you deploy your sentiment model as a separate service, then the custom sentiment analysis tool you build for your CrewAI agent. Its run method simply makes an HTTP request to the endpoint where your sentiment model is deployed.
I see. So the agent's tool just calls the other deployed service. The CrewAI app doesn't run the model itself.
Exactly. It keeps things modular, scalable, and lets you use the best deployment strategy for each component. You're building a system of collaborating services, not just collaborating agents.
That's a much more sophisticated picture.
Mm-hmm.
Which brings us to, okay, you've built this amazing system, deployed it, it's running. How do you manage it long term? It feels like with all these moving parts, agents, tools, external models, LLMs, things could get complex fast. It's not just set it and forget it, is it?
Absolutely not. And this is where MLOps, machine learning operations, becomes absolutely crucial for agentic systems. Maybe even more crucial than for traditional ML models because of the autonomy and sometimes the non-deterministic nature of these agents. If we connect this to the bigger picture, MLOps provides the framework for ongoing management, monitoring, and optimization. You need this for production systems.
So what does MLOps look like specifically for CrewAI systems?
Well, a huge piece is observability. You need to tame the potential chaos of these autonomous agents. You have to be able to see what's going on. This means monitoring key metrics. How many LLM tokens are being used? What's the latency of tasks? Crucially, what's the cost per execution of the crew? These things can add up fast if you're not watching.
Okay.
And beyond basic metrics, integrating with tools specifically designed for agent observability, like AgentOps, is incredibly valuable.
AgentOps, what does that give you?
It provides really detailed session replays. You can see the agent's entire thought process, which agent ran, what its reasoning was, which tools it called, what the inputs and outputs were, the exact LLM interactions. It's like having a black box flight recorder for your crew.
Yeah.
Invaluable for debugging when things go wrong or for optimizing performance.
Wow, okay. That level of insight seems essential. What about reliability? How do you build systems that don't just fall over when something unexpected happens?
Right, reliability is key. You need to build robust systems that anticipate failures. We touched on some of this with tool error handling, but there's more. You can implement task-level guardrails. CrewAI lets you specify things like output JSON or output pedantic for tasks. This forces the LLM's output into a structured format, which is much more reliable than just hoping for the best from free-form text. You can also set human input true for specific critical tasks. This pauses the crew and prompts a human to review or approve the agent's output before proceeding. It's a vital safety net for high-stakes operations.
A human in the loop, essentially.
Exactly, and reinforcing the tool point. Advanced error handling in tools is non-negotiable. Comprehensive try to accept blocks, yes, but also maybe implementing retry mechanisms with exponential backoff for transient errors, like temporary network issues when calling an external API. Make your tools resilient. And remember, CrewAI flows. For those really long-running processes or ones that need to maintain state reliably over time, flows are often the better choice than a standard crew, as they're designed for persistence and handling interruptions.
Okay, makes sense. Build in observability, build in reliability at multiple levels. What about optimizing these things?
Yeah.
Especially around cost and performance, which you mentioned can escalate.
Yeah, that brings us to a really important optimization strategy, strategic LLM selection. This is key for both cost and performance in the long run. The idea is simple. Don't just use one single super powerful, expensive LLM like the absolute top-tier GPT model for every single agent in your crew.
Why not? If it's the smartest, shouldn't it do the best job?
Not necessarily, and often at a much higher cost and slower speed than needed. Different tasks require different capabilities. So the benefit of a multi-model approach is, 1, cost optimization. You use cheaper, faster models for simpler, more routine tasks. 2, performance optimization. You select models that are actually best suited for a specific kind of task. Maybe one model is great at coding, another at creative writing, another at strict logical reasoning.
Tailoring the brain to the job.
Precisely. Think back to our financial crew. The investment advisor agent, the one doing the final synthesis and complex reasoning. Yeah, maybe that one needs the power of a GPT-4o or a Claude 3 Opus. High reasoning is critical there. But the research analyst just gathering and summarizing information. or the technical analyst running calculations based on structured data. They might perform perfectly well, maybe even faster, using a more cost-effective model like Claude 3.5 Sonnet or Llama 370B, or maybe even a smaller fine-tuned model. You save significant cost and potentially reduce latency without sacrificing quality for those specific roles.
So you could have different agents in the same crew using different LLMs.
Absolutely. CrewAI makes this easy to configure. You can specify the LLM on a per-agent basis. There are even emerging frameworks around LLM selection based on agent roles, high reasoning models for managers or planners, balanced models for analysts, researchers, maybe more cost-efficient, or creative models for writers, and specialized models like code models for tool users or coders. It's about smart resource allocation.
Wow, okay. What a journey we've taken here. We went from understanding this fundamental agentic shift and unpacking CrewAI's core parts, agents, tasks, tools, crews. Then we walked through actually building a real system, the financial crew, including custom tools and workflow orchestration. We covered deploying it professionally using Docker, FastAPI, and the cloud, even integrating specialized ML models. And finally, hitting those crucial MLOps practices, observability, reliability, optimization like strategic LLM selection to make it production-ready and sustainable. It really paints a complete picture.
It really does. And I think the core takeaway, if there's one thing to remember, is that building these agentic systems, it's fundamentally about becoming an architect of collaborative intelligence. You're not just prompting anymore. You're designing interactions, workflows, entire systems. The future of complex software, I think, isn't monolithic. It really is, well, a crew.
That's a great way to put it. So the final thought for you, listening. After hearing all this, what complex, multifaceted problems could you solve by orchestrating your own team of specialized AI agents? We really encourage you to think about the possibilities this new paradigm offers, because the power to build your own AI dream team, it's really becoming accessible now. Definitely something to explore.